Right, I'm about to go live. Hi everyone. Sorry about the other link not working, not too sure what happened there. I can see people are slowly starting to join, which is good. It shows the new link is working. So welcome to the 7th in our series of marine tech webinars. My name is Chelsea. I work for Oceansgate, a Plymouth City Council led project, and I'll be your host for this event. Just a reminder that during this webinar, you will only hear myself and our presenter speak. We will not be able to see or hear any delegates. After the presentation, we will be holding a Q&A session. Please use the Q&A chat bar to ask any questions throughout the presentation. If you see any questions you'd also be interested in hearing the answer to, give it a like and this will send it to the top of the pile. Just a reminder, this webinar is being recorded with the intention to be available to others on demand. Enjoy, and I will now hand you over to Julian Ludlow from Marine AI.
Hello everyone, my name is Julian, as Chelsea has said, and I work at Marine AI. I'm one of the software developers there, and today I'm going to be talking around what Marine AI is, what we're currently focused on, and also touching on the Mayflower autonomous ship, although I won't be going into too much detail for that because there's a talk later on in September that focuses exclusively on Mayflower. So I'm going to cover Marine AI, as I've said, Marine AI and maritime autonomy, the kind of problem space we're working in, what the specific problems are associated with merchant shipping, what we're doing in terms of development for both AI and more general software, the Mayflower project, and then I'll just wrap up with a summary of what we've covered before opening up for questions from attendees. So Marine AI then, we're a software engineering firm, and we were spun out of MSubs last year, and we were set up really to tackle the development of more complicated AI-driven decision-making capabilities that can be pushed out to the edge, either on autonomous vessels or in support of manned vessel operations. And so we're not completely separate from MSubs. MSubs has a lot of pedigree in the build of autonomous systems, and they give us a lot of support in the more engineering side, but we're there focused on the software itself. Recently, we were accepted into the NVIDIA Inception program, and that's designed to, as an incubator really, to support cutting edge AI startups and provide access to technology, training, and investment as required. And as I alluded to earlier, we're part of the Mayflower autonomous ship project, and we're working with Primare, who funded the build of Mayflower, MSubs, who are really leading on the systems integration, and then we have a range of partners all delivering capabilities into Mayflower, so IBM and Red Hat, Slingshot 6, who are providing our global communications management capability. Got a satellite AIS provided by Exact Earth, Thales are providing the SATCOM, and we're also taking some 5G capability from Vodafone to look at how that performs as well. So really, I guess back in June when I joined, it was just me, and we built the team from there. But when we started, we were really needed to look at what autonomy really meant in the maritime space, where the problems were and where the benefits would come from starting to introduce AI-driven autonomy into the decision-making process. So we've been working really in the areas that you can see on the left on the slide. So looking at the ethics of AI and the role of sort of decision-making, the ability of a human being to make their own decisions and how that can translate into artificial intelligence. what a roadmap to full autonomy would look like for the maritime space. You know, there's a lot of lessons learned to be taken from autonomous cars in this area. What the enabling technologies are out there at the moment, from robotics through to communications and existing machine learning, computer vision techniques. What support ecosystem would be required for autonomous vessels? So, you know, there's lots of talk of smart infrastructure and what kind of smart ports would be required to support an autonomous vessel transiting to and from a berth, for example, or how can we leverage existing infrastructure and such as the smart sound in Plymouth to not just be a source of data to gather to train autonomous systems, but actually how we can use those sensors to push that support back out. So if an autonomous vessel is operating in the sound, can the smart sound infrastructure support that vessel in what it's doing? Through to looking at testing, both in terms of the software, the hardware, how we integrate that and then test a complete autonomous system, through to really how we start testing for safe decision making. So when you're talking about moving a decision from a human being and vesting the authority for that decision making in a machine, how do you test that that machine is going to make the right decisions at a consistent level? That means it's safe to have that decision making authority. We've also been talking to the MCA and Lloyd's Register around regulation and what kind of regulation is required for autonomous vessels, and what the roadmap would be to work with agencies like that to develop frameworks, etc. That really, I'd say we're at the beginning of the journey, both in terms of development of these systems through to how we regulate those systems. So it's really everyone's moving hopefully together as we mature our knowledge and what the art of the possible is. And then finishing up in the security. So that's not just in terms of data security and onboard encryption of data. It's the physical security, the assets. You know, there's nobody on board to prevent people interfering with these platforms. So what kind of things can we do to address those problems? So as part of the research, we really started to dial into the merchant shipping area as a problem space. We wanted to really look at areas which accidents might be low frequency, but they have high impact. So, you know, environmental damage, loss of life, loss of equipment. Really, if you look at the research done by insurers, the average loss cycle of a cargo vessel or a passenger ferry is costs around $4 billion. So these things are expensive to lose, and accidents are also incredibly damaging. I mean, there was the recent accident in the Mauritius where a tanker ran aground. So coupled to this, we've got the sort of marine accident investigation report showing that operators on board modern vessels frequently suffer from sort of cognitive overload. It's really, they've got a host of sensors, they've got a host of alarms, there's screens everywhere, and then you've got the external pressure of navigation constraints and complex shipping situations. And really those together mean that you know, even though things like electronic charting, the ECTIS I've listed there, is a good system, it's also quite a complex system to use. And when people are trying to use complex systems, in complex shipping situations or constrained navigation situations, then the probability of an accident occurring increases. There are also evidence of poor standards of watchkeeping and poor passage planning and you know, general falsification of records, etc. But these all point towards sort of propensity of human beings to make errors, and often make errors at the worst moment in time when you're dealing with big, expensive assets with this potential to cause huge amounts of harm and potential loss of life. So for us, that was a good area to focus on, looking at AI and how it can benefit this, reducing the probability of accidents by offsetting the shortfalls in human behaviour at sea. So we also then started to look at other areas, like we've got the smart sound, but how do we then take that data from the radars, the cameras, the AIS, and assure that data so we know it's good quality, there's no bias being introduced to any model training down the line, that we can version this properly, and that the data itself is both stored securely, but there's no way of potential cyber threats being introduced into data sets from external parties breaching security within the smart sound itself. And that's an interesting area, because it starts to trend into, if we want to support human decision making to reduce the probability of accidents, then are we talking about safety critical software when we talk about autonomy and AI in support of operations on large vessels, at a large scale across a complete merchant fleet, for example, that might be carrying cargo, but it might also be carrying oil or other dangerous goods. So there's a question there around, which still hasn't been answered. This is part of what we're discussing with Lloyd's, for example, is at what point does the requirement demand that safety and a fail-safe system be developed in terms of software. And really all this is coupled to how we build trust in automated decision making. Trust from the regulators, trust from the operators, trust from insurers, and trust from the general public, which can be seen again in autonomous cars. So there are good lessons to be learned from that area. So we took that sort of approach and the research that we'd done, and we started to really focus in on specific areas we could look at as a development team and start to make concrete capabilities. So things like the decision-making cycle for complex shipping, how we can leverage autonomous platforms. Autonomous platforms are good for us for experimentation and to really take that standalone capability that's developed in the lab and integrate it into a live platform and get it onto the water and start gathering real-world performance data to see how it operates in shipping and navigation situations without the additional burden of sort of manned interference and overhead that you'd get on trying to integrate onto manned ships, which are trying to do their job within the constraints of the company and the law and their own timescales. We're also looking at cybersecurity, what cryptography we can use on board, how we secure end-to-end communications, and this is an area that Slingshot 6, for example, have been incredibly helpful with, because they've got a very robust ship-shore communication system, and they've really been excellent at helping with that. Through to, as I alluded to earlier, data management. We're not just at the training stage, so smart sound, when we're capturing that initial set of data, looking at the models, using the data to train the models and see how those models perform. It's also around how we are doing that on board the vessels. So we've got these sensors, we've got cameras, we've got a radar, we've got AIS, and how we fuse that data together to make an enriched message that can be used by AI decision making upstream, and how we store that on board and secure that storage, and then how we transmit that back to shore in a manner that's useful. And again, we had data science is reasonably mature now, and there are plenty of lessons to be taken from that. What's the value of data science in business? It largely, and business intelligence in business, it largely boils down to effective communication. So decision makers are less interested in seeing the complexity. They want the ability to have that information presented to them so they can make a decision. So those kind of problems are in that data area. As I've alluded to, we've got this potential for SIL requirements, although we're not there yet in terms of, I think, understanding the full picture for how autonomous vessels operate at sea to really say where those SIL requirements sit. We have the traffic control for autonomous vessels. Again, this is linked to smart sound and linked to areas that we're working on in that how can you spin out the capabilities that were initially established to allow data gathering to train AI to then support capabilities that talk back to the AI or autonomous vessel and allow it to transit areas which are hugely complex in terms of the surface picture. You've got, because you haven't just got an AIS or radar picture, you've got tiny little boats, you've got kayaks, you've got paddleboarders, you've got swimmers, you've got marine life, and all intermingling around these. If you take Plymouth, for example, they're around the deep water channel, in and out of the dockyard and the port. So it's this role of traffic control and what capabilities that traffic control needs to have is an interesting area. We also looked at the role of vision. Computer vision is important. It's an interesting area, and really, at the moment, I'd say we're at the point where we can exploit very effectively traditional sensors, but now we want to push beyond that and say, how can we implement visual cognition really properly? How do we understand the maritime scene from the perspective of computer vision? So that's not just object detection, object classification, and object tracking. That's starting to pass the scene to look at less clear objects, maritime objects that might be partially obscured, or very small objects that don't necessarily have an associated radar or AIS signature, and also looking at how you can understand bearing, movement, and aspects of that within that visual scene. So, what's the aspect of that vessel? Is that vessel moving away from me? Is it closing? So, it starts to place computer vision as at a level of importance that radar currently holds, for example, because you can get a lot of rich information from radar, and we want to establish computer vision to be as rich, and really the option as a fail-safe should radar fail. We also had to integrate the constraints. Obviously, we're not working in an area that's free from rules. And we have the collision regulations for the rules for prevention of collision at sea. We also have safety of lives at sea, especially Chapter 5. And any autonomous vessel that hopes to have the ability and the license to make decisions on its own needs to take these rule sets into account. It can't ignore them. But at the same time, if you look at how other vessels operate on the sea, not all vessels necessarily comply completely with collision regulations. So these are fuzzy problem sets because they're human rule sets. And so how do we implement those on a deterministic platform? Again, that's one of the areas that we've been looking at. And as I've alluded to throughout this, we've got this command and control. How do we vest command and control in an autonomous agent? At what point do we say we as a human being can no longer keep up with the speed at which that platform can make a decision, and we cannot match it in terms of accuracy, and we've tested it and we know that this knowledge is sound and that it understands to a certain degree what the problem set is that it has to deal with. Again, we're not there yet, but this is something that really has the greatest level of impact, to me anyway, on the ability to establish valid regulation in this area. How do we control autonomy levels, etc.? And that links to this roadmap from human in the loop, where you get sort of what we're seeing at the moment, where people are controlling vessels, remote control vessels, which is entirely valid. The vessel itself is autonomous. It can carry out autonomous functions. It's a maritime robot, but at the same time, safety is assured by the human in the loop, robust ship-shore communication, video streaming, etc. So people can make decisions based on what the surrounding shipping situation and hazards are. And obviously, as I've said, it's important and critical to engage with people like the MCA, like Lloyd's and insurers, to look at what their concerns are and where they're going with this, because there's no silver bullet coming from business, and there are no silver bullet coming from any other area. It's going to be a joined up process to get to the point where people are comfortable for autonomous ships to operate in the same water space, especially in shore and in harbours, as manned vessels. So this boils down to Guardian, which is our product set, and we've got two product concepts that we're developing. One is Guardian Manned, and the other is Guardian Autonomy. And they're the same tech stack, they're just targeting different platforms. One looks at interfacing with the autopilot and enabling, decision-making driven control of an autonomous vessel, still with human in the loop though. And the other one is Guardian Manned, where we look at alleviating the cognitive burden on operators with regards to shipping and navigation decision-making across all levels of complexity for those. And there's some side benefits for both as well. But really, we're looking at a single tech stack being deployed across two use cases, initially really focusing on the manned, but over time, as regulation moves forward and technology moves forward and capabilities move forward, moving into the autonomous space as well. So I've spoken a lot about sort of what marine AI has been doing. It's been a lot of research, a lot of concept development and design, and really starting to get those initial prototypes out and working and tested in the lab. And we have an integration facility on the waterfront in Plymouth that we do some initial sort of shore-based integration at, just to see how data fusion can talk to the application layer, for example, and then the applications can integrate the output and do what they're meant to do. But Mayflower, I said I'd allude to it. There is a main talk on the 16th of September, but this is a really exciting project. It's Primari built it. MSubs have really integrated everything, and there's IBM in the mix and a whole range of other companies as well that are all providing sort of excellent capabilities to support this voyage. But really, it's leaving here, Plymouth in the UK, and it's going across to the USA. Initially, it was going to be as part of the Mayflower celebrations, but because of COVID, all that got sort of moved around and a lot of it became virtual. So we're looking at really sailing across sort of early next year. But it's been a really fantastic collaborative project, really. So Marine AI, small as we are, have been working with MSubs. It's where a lot of our sort of AI research has met the engineering and systems integration capabilities of MSubs, and really it's great because you need to understand what the control systems require in terms of data feeds, and they've been able to help us in areas like that, but also helping us with the integration of third-party capabilities like the Slingshot 6 communication system. It's they've been brilliant in that. So and they obviously have a good pedigree in robotics as well. IBM have been fantastic. We've been using visual insights from the Watson stable to look at some initial computer vision model development. That's alongside sort of NVIDIA capabilities as well. We've looked at how you integrate deterministic rule sets. I mentioned it earlier with collision regulations and SOLAS, and so we investigated a piece of technology that they use actually in finance to validate online behavior from customers. And yeah, it's an interesting use of a technology for that's been designed for and really focused design for one particular market segment, and how we can take that and re-roll it for a completely different use case. And IBM have been very interested in this kind of reuse of existing technologies within their catalogue for something that they never envisaged it being used for, really. A really important capability, and one of the areas I've been working in, is optimization. And again, the optimization team at IBM have been very helpful and supportive in that. We've also got the IBM weather, and there's some ship-shore communication experimentation with the IBM Edge, which is the Exchange server, and onboard node, which is one of their experiments. On the Mayflower itself, we've got experiments run by us. So I would say anything beyond an existing acceptable robotics standard, so the M-subs layer, is very much, we're using the Mayflower Voyage to really capture the performance data that we need to start to look at how we validate AI-driven decision making, so we can use these results to improve the Guardian stack, but also look at share it with the MCA, with Lloyd's, and say, this is how this kind of system is performing. This is how you make a decision when there are multiple ships, all with separate collision regulations attached to them. And with separate collision regulations attached to them means they all have different reaction recommendations. So what do you do in that scenario? Well, as a human, you can always turn back to your experience and your training and what the rules actually say. So how is that being translated into a sort of AI decision making? IBM are running experiments there as well. There's also some additional environmental work going on, sampling, water sampling, etc., microplastics, which is excellent. There's some computing experiments being hosted on board, and yeah, it's a Mayflower really, I guess, instantiates for us as marine AI the ability to shift big data gathering and analysis, storage, exploitation, really, from a data center, very energy inefficient, requirement of huge amounts of bandwidth for network bandwidth, etc. Shift all that to the edge. So not just compressing down a single model onto, say, an NVIDIA Jetson, which can sit out and run your computer vision models on a lamppost. That's a good use case of that kind of technology, but it's moving more than that. It's moving the Jetson and the actual brains to the edge in a low power, space constrained environment that moves around, fluctuates in temperature, has the potential to get horribly wet, and really say, well, we can deploy this and look at the use cases where we can start to say, we can send an autonomous vessel out equipped with a range of oceanographic and meteorological sensors, and we can do proper scientific surveying remotely, and the scientists are merely getting the results of the onboard analysis back. So rather than trying to clog up communication pathways, SATCOM pathways, with vast amounts of data, trying to stream video, etc., the analysis of video, the analysis of sensor data takes place on board, and the results are shipped back. And that's really what we're trying to look at the potential for with Mayflower as a at-the-edge scientific platform. Just really finishing up then. So this kind of just gives a pictorial demonstration of what the Guardian looks like on board Mayflower when it sails. It's very simplistic, but yeah, we've got sort of the tech stack involves storage. We've got the sensor data, we've got weather data, we've got rule sets data, and from that we have the ability to derive action recommendations from a combination of capabilities such as optimization. And those action recommendations are integrated into the onboard decision maker that allows the vessel to make course and speed changes based on shipping and navigation constraints in the area. The caveat to that, of course, is that we are very much at the stage where humans are still in the loop. So we'll always have the ability to monitor what the vessel is doing. And there will be a definitive point at which autonomous becomes semi-autonomous, and human beings are making, the course decisions. And that's a necessity at the moment. We are not at the stage where we have the technological maturity to say, we can send something from a berth to another berth completely autonomously and safely. So, but that's the route we want to go to, and that's the aim. So, as I've said, what we're trying to look at with the voyage is, can we reduce the cognitive burden on shoreside operators? In a very complex scenario, is it easier when a recommendation that you trust is made, rather than trying to interpret the situation yourself, plus do everything else that you've got to do? And does this, in effect, reduce the probability of collision or grounding? This is the kind of thing that we need to go to sea and gather the data to demonstrate or try and prove. Because we capture all the data, obviously we do support post-event reconstruction, so we can we will be running a complete reconstruction of the voyage as it happens, to see where potential failures can occur, will occur, etc. We can track what decisions are being made, what the routing is. We've got sort of what role looking at what role for the RCC operator. So RCC, sorry, is the remote control center. What role the RCC operators have in feeding back whether the decision making enables better safety in their own decision making. We integrate weather, we integrate the collision regulations, we also integrate SOLAS, and we're also integrating the navigation data as well. Okay. So hopefully that's been informative and interesting. Yeah, we're involved in quite a bit, because we're sort of ranging from the quite abstract, and a project I'm involved in separate to sort of Mayflower is sort of AGI, so artificial general intelligence, but that's at the stage where it's still very abstract, but it has links to the kind of work for Mayflower and Guardian, in that there is this long-term role of sort of the ability to, at the moment, organisations are comfortable investing responsibility for decision making in control of complex assets to a human being who has the requisite training and experience, demonstrates sound decision making, etc. And it's very grey and fuzzy. How there's no simple way of saying, well, it's okay, we'll automate that by doing this, because that's not how it works. And we've got to find a synergy with how autonomy operates in conjunction with human beings, and that's going to take time, but it's interesting. And yeah, we're using Mayflower as a experimentation platform to support autonomous operations, and really using it to develop our own capabilities, instantiated in the Guardian brand. And as we say, we feel that decision making, AI decision making, does have a role in reducing cognitive load. Ships have been loaded with more and more systems without any real view on the effect of the operators on those, of adding all those systems. So can we offset that by automation? And if we can offset it, can we then reduce the probability of groundings, which have such devastating environmental impacts and huge financial costs, and the potential for loss of life? And yeah, when we talk about AI, sort of, and I guess this is true for all AI or companies involved with AI research or AI capability development. It's not a single solution. You know, we're not just saying we're going to create a computer vision solution that's going to do everything, or some statistical technique that's going to solve things. There's a whole range of areas which are still at the early stages of research, such as sort of causality, for example. How do you integrate causality into things? How do you transition from a very sort of deterministic inference layer where the training cycle, you train a model, you then deploy that model with no real capability to improve its performance other than slight tweaks to its weightings, through to something that can learn at the edge. Things like that are again interesting and areas we are working on. And yeah, Mayflower is a brilliant project that really gives us the opportunity to put a lot of our thoughts and concepts into practice and see where it goes. So that's it from me. I hope it was interesting, and any questions?
Thank you for that, Julian. We have had some questions coming through throughout the presentation. If anyone else has got any other questions, please start typing them in the Q&A question section and we will try our best to answer them. So the first question is, what standards are there for marine autonomy? Are your systems similar to air and land autonomy?
Yeah, so there's no real defined. So in terms of, I guess we're talking about SIL levels, so SIL 4 to 1, etc., that you often see in safety critical systems on land, etc. For autonomy, and by autonomy I mean really the area that we're working on, the AI. It's still very, very early stages, and there are no real defined or explicitly defined standards for AI that has the potential to impact on safety. However, logically, you could say if you wanted to apply those standards, then you would apply something like SIL to the development of those kind of capabilities.
Okay, next question is from the MCA. I would be very interested to know how far we have come with respect to Reg compliant navigation. I was under the impression this still have not been achieved. Can you shed some insight into the development of your systems and how far away you are?
Yeah, so Regs is an interesting set of rules from an AI or autonomy perspective, because so where we're at, I guess, is that you can quite easily deal with rules like that are based around trigonometry, for example. You know, the determine what is an overtaking vessel, what is a stand-on vessel, what is a head-on vessel, what is a crossing vessel stand-on, what is a crossing vessel give way. You know, you can calculate their aspects, bearing, etc., from radar and using basic trigonometry to classify the vessels around you in accordance with that. You know, so that is really where we are at the moment. So we're not, I wouldn't say fully Reg compliant, or full Reg compliance will be achievable in the short term. There are lots of interesting areas like safe speed, for example, in calculating adherence to safe speed. You know, there are factors like background lights, traffic density. Well, those are interesting problem sets in their own right that aren't answered by trigonometry. And you've really got, so the model I tend to think about it as is, at the moment we've got you're going to have a range of capabilities whose outputs all contribute to your ability to comply with collision regulations. At the moment we have a sub-agent that can do the necessary calculations on bearings and angles to determine some of those rules. And where we're working on at the moment is another sub-agent that looks at traffic density that will help comply with another rule, or a subset of another rule in terms of, say, speed. But we've got to capture the data and train the models necessary to comply in other areas like lights and shapes. What about sound signals? All of these will be sub capabilities or separate capabilities, sub-agents really, whose output all contribute to a Colreg flavored understanding of the surrounding environment for an autonomous platform. So yeah, we've started, but we're not at the end point by any means. I hope that answers the question.
Okay, thank you. Next question. Do you have Sonar Capability, tool for complex navigation in the natural world?
No, we don't. No. You're talking about Mayflower. No, I don't. Mayflower's not equipped with that.
Okay, next question. Who is going to take the lead and fund the kind of smart infrastructure and regulatory evolution that will make it possible for marine AI to succeed?
Yeah, I mean, it's going to be, although it might be an overused phrase, it's going to be a joint effort, because people have ideas, and if you can get funding for those ideas, whether you work for a business already that wants to get into that space, or you start up on your own, you then start to naturally, you're going to have to collaborate. And so you naturally engage with the MCA, with Lloyd's, with Marine Accident Investigation, with even the IMO, for example, from the regulatory aspect, through to other businesses, through to sort of the smart sound kind of infrastructure, etc. So I think that it's very hard to pinpoint where I think the overall funding is going to come in bits and pieces from various areas. There's innovation projects that you can bid into, the government fund innovation sort of research. There's defence research in this area as well. So it's that business will fund part of it, coupled to either from their own pockets, from VCs, or from investment from government, coupled to government will invest in it because they are funding the regulatory bodies that will help shape the regulation. So yeah, there's no one single source of money, I would say.
Okay, next person. Hi, really interesting talk. When is Mayflower due to sell, and will it be autonomous given what you've been saying about progress to date?
Yeah, so what Mayflower, Mayflower goes into the water in September, and we start sea trials in September. She's due to replicate the Atlantic crossing in April next year, I think, which gives us a nice amount of time to do the sea trials and make improvements, etc. In terms of autonomy, so I guess it's the kind of problem that's facing autonomous cars as well, is that we have to operate in a hybrid state where some portions of the journey are semi-autonomous and other portions of the journey are autonomous, and that is driven by safety. So if you are operating in Plymouth Sound, for example, you're semi-autonomous. You're being, there's an escort vessel. You are linked to that escort. You, as the autonomous vessel, are linked to that escort vessel, and the escort vessel influences your speed and your course. Yeah, and that really is, aside from the remote link, it might as well be, a human captain at that point. But and that's recognizing that, as I've said, the ability for a system to comply with a very complex set of rules and regulations that alternate between that classic fuzzy rule set that humans are good at, versus, you know, very binary. You either comply or you are in breach. Will require a nest of sub-agents, all supporting a ultimate decision maker. And we are on the journey to that, but we are still far away from that for collision regulations. So we have to make a judgment when it's safe to switch to autonomous work, but and that's likely to be the open ocean. So really, if you bridge it between the continental shelf and sort of, I guess, where we are in the world, the Scilly Isles, sort of from the Scilly Isles out, you could probably operate quite safely in autonomous mode. But on the continental shelf, with that increasing fishing vessels, the increase in shipping complexity, you have to look at semi-autonomous operations as the default safe state to be in. Other than you can set, you know, you can operate within a set area, for example, at a range, and test out autonomous operations in that zone. But in terms of transits, journeys, etc., you're going to have this split between semi-autonomy and full autonomy.
Okay, next question. Can I ask what effect this may have on jobs in the future?
Okay, what jobs? Sorry, I don't want to answer a question with a question. So if I was to say jobs at sea, for example, I don't think in the next decade or so it will have much effect on jobs, other than to enable people to do their jobs better. You know, we're talking about autonomy in support of shipping operations and merchant ships, etc. We have a long way to go, as I've said. It's really, the problem is very, very human. It's, if I was to give you millions of pounds worth of cargo and ask you to transport it from A to B, what assurance do I need that you're going to do that safely? And you can take that, you know, it's that trust. If, at what point are we going to give that to a ship and say there's no one on that ship, it's fully autonomous, let's go from A to B, and it's taking all my millions of pounds from A to B, and it's not going to hurt anybody, and it's not going to crash into the rocks and cause vast environmental devastation, and I trust that it's going to do that. And that, I think, is what people see as the point at which jobs become threatened. But when we reach that point, I don't know. And it's not in the immediate future. And I don't think this is a threat to jobs as people may think it is. I think it is an enhancement to their jobs, because it will enable them to operate in a safer manner. And then certain areas, like, I'm not sure many people want to sit in a 15-meter ship and go off to the Arctic, for example, to do surveys. So, you know, things like that, where deploying into more hazardous areas to do scientific surveys actually helps with general health and safety, and allows the scientists to stay at home and do their jobs from the safety and security of their office. Then that's a benefit too. But the overall trend is, you know, autonomy is happening across multiple market segments, but the point at which it threatens jobs in the maritime industry, I think, is some time away.
Okay, next question. What would be the consequences if autonomous ships were, autonomous ships were hit by normal, I think that is meant to say autonomous. What would be the consequences if autonomous ships were hit by normal ships, or normal ships were hit by autonomous ships? Which rules can be applied in this complicated situation?
Yeah, so this is what I was saying about agency and about vesting command and control in autonomy. Until we're at that point where we can do that, which I've spoken about before, I don't want to bore people by repeating myself. It's, you know, there's always going to be this human in the loop for the foreseeable future, and you have responsibility for command and control. Whether you say, well, for that portion of the journey, I'm going to let the vessel take the decisions on control, control surfaces, speed, course, etc. That doesn't divest me of my legal responsibility for what that vessel does. And I think within that scenario, which again ties into sort of more where regulators would probably be a better place to answer this than me. It doesn't matter who hits who. I mean, in terms of the physical effects, it depends on the size of the respective vessels. But in terms of the legal effects, whoever's ultimately in command and control of that autonomous vessel is going to go to the same maritime court as the captain or owner of the manned vessel that was also involved in the collision, and they're going to make their cases accordingly. And I think that it's going to be a long time before we can say, well, it wasn't my problem, it was the autonomous system. There's the human in the loop applies to legal responsibility as well as sort of the at-sea systems.
Okay, we'll take one more question. This is from Eric. He said, hi, sorry I missed the beginning of the webinar. Will you be making a recording and or the slides available? Yes, Eric, this is being recorded live as we speak, and I will send everyone a copy of the recording, which will be on our YouTube channel, just in case anyone did miss anything or wants to recap over anything Julian has gone through today. Everyone has my contact details, so if anyone has any further questions or wants any more further information about Maritime, please let me know and I can pass you on to Julian. Julian, is there anything else from you today?
No.
Okay, everyone, sorry again for the complications at the beginning, and thank you everyone for joining. I will now bring this webinar to a close.